Let's assume the room is about the size of this one. I'm sure a few of you will be like, well, if it's a football stadium, then I'll have frustrated and stuff. So let's just assume it's a normal size classroom. You know, papers more down. Also, I did grade your quizzes. The grades are in the grade book. So if you notice that your grade took a nosedive, the relearning activities are already listed on Canvas at the end of module 3. So you can do those and retest as soon as possible, so you don't lose your early lunch for too many days in a row. Haven't taken the quiz, come in during Marshall time as soon as possible to take it. Okay, does anybody have any thoughts? How many rows of desks do you think you could fit? Ben?
4 rows.
4 rows? Okay. Any other thoughts? There's not necessarily right or wrong answer to this, people. Keegan?
Can you stack the rows on top of each other?
Could you sit in a desk with another one on top of it?
If you try hard enough, someone.
Yeah. You would not be studying very effectively if someone was sitting on your head. Luke?
5 maybe.
5 maybe? Your baby's in version 6. Okay, so what would be a reasonable number of desks to fit into a classroom?
Reasonable number?
Mhm.
About 5. I think it depends on how many people there are, so like.
But it's asking about how many desks could you fit in there. Link?
That's cool.
30? 30 is a pretty reasonable number for most classrooms. So once I hit 30 in here, I start to feel like I can't breathe. It's very full, very fast. Unless you like line them up like it's prison. Well, the classroom's awful boring. All right, so what number of rows do you think would be impossible? Finn?
Any amount of desks over 50.
Okay, more than 50? Luke?
Anything that is more than 100 for either of them is way too much. Well, with
Okay.
spaces maybe 7 or 8 rows. No.
7 to 8 rows, okay. What do you think that the answers reveal about the graph? If we were to build a graph with rows on one axis and desks on the other, what do you think would happen with that? What would it look like? So was that a hand raise link? Okay. Every time you added another row, what would happen to the number of desks?
Like 25.
By how many?
Many you put like that.
How many are in a row? 5. So every time you add another row, how many more desks do you add? 5. So what would that look like if we graphed it?
Yeah, it would be
What scale would we wanna use?
Uh,
You guys know what scale is?
one,
How many would each tick mark be worth?
one.
One? Okay, you said probably eight's probably the max we'd be willing to do. Do we wanna go by ones on this side too? What do we wanna go by on that side?
5,
5. How come?
because everyone goes 5. So, if you go, whenever you go over x1, you'd be going up 5.
Okay, so what would it look like? Straight line. Alright, 1 would be 5. 2 would be 10. 3 would be 15. My tick marks are not perfectly spaced. Right, but it's gonna be a straight line. So is that a relationship?
Yeah.
How come?
They're all,
Finn? It's okay. Guessing is good.
If the number of desks on each row stays the same, then no matter how many rows you have, you'll always have the same amount on each row, I
Okay,
guess. So they're related.
they're related. Okay, so a relation. Got some vocab words for you here. Really gotta re-clean my board and recommission it before Thanksgiving break. It's getting way too hard to erase. I was unable to grind it just recently. Okay. Vocab words, you ready? Anybody remember what kind of stuff you're supposed to write down when you take notes in math class? Definitions is definitely one of those things. Okay. So I'm gonna write a chart down and then we'll cover the vocab words. I copied that one. I got it through. Okay, here's my first question, okay? If this is a function, what is the domain of a function and what is the range of a function? Anybody remember what domain and range is?
I know we went over it, but I forgot.
Okay. Jeremy doesn't like that I put 2 13s on there. Like, I'm aware, I did it on purpose. Huh?
13, because you want
I
to
know,
make
right?
it more different.
It's not necessarily about difficulty. Okay,
Actually.
okay. Anybody know what domain is?
It's a thing in math.
It is a thing in math. The domain is the stuff that goes into a function. The range is what comes out. Typically, by convention, inputs are X, outputs are Y.
Input, output.
Right, so the top row would be our input,
Bottom equals output.
bottom row would be our output. Markers down.
Because for the first thing, it makes sense with the lines.
Okay, so which one is the domain?
Main is the X.
Domain is X. Range is
Y,
Y.
Y.
Okay, raise your hand.
Y.
Okay, so X values are your domain, Y values are your range. And this is one way to keep it straight is that it goes in alphabetical order. Right, X to domain, range to Y. Okay, and there's a few different ways you can write this. We'll get to that here in a second. Okay, so some of our vocab words, a relation. We're gonna put that back in there and now I get to pop it right back out again. Fun times. I want to make sure you can see that far on the board. Barely, okay. We're in range. Could always just push the desk back. Then he gets more bored there. Okay, so a relation is a set of ordered pairs. If you can put it into a set of ordered pairs, then it is a relation. What is an ordered pair? See how much proper vocab you guys learned last year. Check. Anybody remember? I can't even guarantee that your teacher last year used proper vocab, so I don't know if you know what an ordered pair is. An ordered pair is a coordinate point.
I was like just barely on the.
Okay, if you can make your set of data into ordered pairs, then it is a relation. So looking at this one, is this a relation?
Yeah,
Okay, what are our ordered pairs?
1 and 11. 2 and 12. 3 and 13. 4 and 13 and 5 and 15.
Okay, it's made of ordered pairs, therefore it is a relation. Okay, next is functions. Does anybody know how we can tell it's a function?
We like touched on this last year.
Anybody? Anybody know how to, if you're looking at the graph?
What?
Either our brains have completely forgotten everything we learned last year,
That's something that would happen to me.
or we didn't learn a whole lot of this last year.
And that also.
I'm assuming both.
Yeah.
Okay, so a function is a relation where every input is assigned to exactly one output.
Something for this.
Okay, when you're looking at the graph, that means it passes the vertical line test. Have any of you heard of the vertical line test?
I've heard of it, but I don't remember what it is.
The vertical line test means if you can draw a vertical line anywhere through it, I'm trying to make sure that when I record this, I'm the big thing and Jeremy is the small thing. Okay. So that means if you can draw a vertical line anywhere through and it only ever crosses once, then it is a function. Okay, does that make sense? Because that means for every X, there's only one Y. Okay, that doesn't mean that the Y's only appear once. That means for each X, there's only one Y. Okay, for example,
So it's only one more.
if I grab a quadratic function, this would pass the vertical line test, even though they have the same Y values at least twice. Okay, because it would pass the vertical line test. Now, if I were to graph a circle
It would not
or
be-
rotate this function 90 degrees even, does it pass the vertical line test anymore?
No.
No,
But now
so it is no longer a function.
That's the horizontal one.
It would, but it doesn't pass the vertical, it has to
Why
pass
does
the
it
vertical.
pass
So this one does, because it doesn't matter where I draw this line, straight line, it's only gonna cross that once. Right? So that makes it a function. This one, it's gonna cross twice. So it is not a function. So if when I draw my vertical lines, that only crosses my parabola one time, it's a function. If it crosses it more than once, it is not a function. Okay. It can only have one output for each input. So each X has only one Y. Seeing after school today, it's getting bad fast. Okay. Okay, we already covered domain and range. And talked about how conventionally the inputs are the X values and the outputs are the Y values. Okay, so is this one a function?
Hold on. No.
How come? Jeremy says, yes, it is. I need to hear some arguments, people. Why is it or is it not a function?
Because three of them are assigned to 13 3 times, so it's not a function.
Okay, so here's the tricky part about functions. Okay, so I'm gonna show you guys how to do this thing called mapping. This is one of the quickest and easiest ways to tell something is a function. These are my X's, these are my Y's. So my possible inputs are 1, 2, 3, 4, 5. What are my possible outputs?
11, 12, 13, 13, 13.
So 11, 12, and 13.
Mhm.
Okay, so you write down your inputs and your outputs. And then we're gonna draw some arrows. So if my input is 1, what is my output? Okay, if my input is 2, what is it? What's my output?
12,
If I put in 3? If I put in 4?
13,
If I put in 5?
13. Whoa, that looks so simple.
Doesn't it? Makes it look very organized, which I like.
Then that one,
Okay,
looks terrifying.
as long as there are not 2 arrows coming off of one of my inputs, it is a function. If there's more than 2 lines coming off one input, going to 2 different outputs, it is not a function. So it's less about what comes out and more about what goes in.
Why are 3, 4, and 5 all 13?
Let's think about what that looks like when we graph it. Okay, and I bet that will help it become clear. So if we were to graph this function, you guys are probably used to looking at constant functions. You just go up to 5, right? Okay, so at one, our output was. What's my output at one?
11.
Output at two,
Well,
if I connect these. Right, it's gonna go like this. Is that still gonna pass my vertical line test?
no.
Yes,
Oh,
because we're talking about vertical.
yeah, so it doesn't
Right.
pass the same.
So just because it evens out and goes flat, doesn't make it not a function.
That just makes it.
If
so
it goes
doesn't pass-
vertical, then it's not a function.
It just doesn't pass the horizontal one.
It does not pass the horizontal line test, and we'll get to what that means here in just a second. As long as it would still pass the vertical line test, I'm okay. So it just means that that line flattened out. Couldn't go any higher. Which happens with several different kinds of functions. So it's more about, as long as I don't have like 2 go to 12 and 13. Then we're okay. So as long as each one of these goes to one of these, and there's not 2 lines coming off of an output, we're okay. If we have the same output twice,
That's not.
and it goes to 2 different y values, then it is no longer a function. Okay, now when we write our domain and range of a function, there's a couple different ways we can write it. So I'm gonna teach you guys interval notation and set notation. Cause we know, that. Gotta write down all of our different ways we write things, or else you're gonna get confused when you see different things. Okay. One thing to note though is if it is not a one-to-one function, meaning if one of these goes to more than one of these goes to the same one of these, it can no longer have an inverse function. Okay, it's not a one-to-one function, it's a one-to-many function. So one of these, each of these only have one output, but several of them have the same output, means it's no longer one-to-one. So that's where you get that differentiation that your brain wants really bad. Is that if they don't go one-to-one, it's not a one-to-one function. And there are some limitations with those. Okay. We all have our mapping written down, so we know how to do that. Okay. Let's teach you guys a couple different sets of notation. Okay, first off, function notation. Function notation, you guys are very used to seeing your stuff written like this, y equals mx plus b, correct?
Yeah.
You're used to y equals. Wish I had my
What about X?
TikTok pulled up. There's a TikTok about this.
X equals.
Hmm?
There's gonna be like X equals
No, so here's the thing.
some other.
Function notation says f of x. A function in terms of x. Is how that is read. Okay, function in terms of x. F of x and y are the exact same thing. They are interchangeable. Okay. So on your calculator, if you try and graph something, it's gonna say y equals. If on your paper it says f of x equals, that's okay. Don't freak out. Y and f of x are the same thing.
Write down Y equals F of
Okay.
X.
So don't freak out about it. F of x and y are the same thing. They are interchangeable. Okay, one is just considered function notation and one is not. That's the only difference. Okay, but we read it as a function in terms of x. Okay, everybody okay with this?
Yes, I wrote it down.
I promise you, half of you are gonna forget that f of x and y are the same thing.
No, I wrote it down.
It doesn't mean you won't forget. Okay.
You just find it.
So this is function notation. Okay, when we're dealing with functions, we often want to find their domain and their range. There's a couple different ways we can write this. Okay, So I'm gonna do interval notation. I personally don't care which way you do it, though I may ask you on a quiz or something to do it in one of the two different ways. Because IXL likes it certain ways and will ask for it certain ways. The college math program asks for it certain ways. So I wanna make sure that you are used to both. Okay. So interval notation for domain and range. I always put a D for domain and an R for range. Just to make it perfectly clear to whoever's reading it, which one I'm looking at. Interval notation uses parentheses. And you either, it depends on if it. I think we talk about continuous and discrete next time. Pretty sure. Oh, nope, it's this one. Okay, good. All right, it will depend on what kind of function you're looking at, but we're gonna use this one right now. Interval notation, you would put in the numbers that are included as your inputs. Like in this one, we have a very limited set of numbers, right? So I would put a parentheses that opens it, and then I would write down the numbers. Can be 1, 2, 3, 4, or 5. Those are my only inputs. Does that make sense? If it was the equation of a line, then I would write it a little bit differently, and I'll show you that in a minute. For the range, I'm going to do the same thing. Right? What numbers are in my range?
11, 12, and 13.
11, 12, and 13. And just because it shows up more than once doesn't mean I need to write it more than once. I can still just write it the one time. It's just telling me what numbers could come out.
You can write it like
Okay, and these are what we call discrete. Meaning there's only very certain numbers that are included. Right, somebody make up an equation of a line for me. Somebody give me a slope, pick one, I don't care what it is. Luke,
5.
somebody give me a B. Is Luke the only one with a voice this morning? You can make up anything you want. Okay. When we have a line, what is the domain of a line? What numbers could we put into this? Is there any limitation to the numbers that we could put into this?
No.
No, we could put in any number we want. So for this one, my domain would be from negative infinity to positive infinity. If I was doing it in interval notation. Okay, let's say I was talking about the desks in the classroom though. Is there a limit to what my inputs and outputs are for that? What's the lowest number I could put in?
1.
One desk?
0.
0, I can have 0 desks,
You
right?
cannot put a negative though.
But I cannot have negative number of desks, right? That would be impossible.
You can't.
So, if I was looking at that one, I would have a square bracket to indicate that I'm going to include the first number. Okay, a square bracket means you're including that first number. You can never include infinity, because there's always one more number past it. So I could have 0 desks. What did we say the maximum number of desks I could have?
Like, at most, I'm thinking.
In this room, I will tell you, you cannot physically fit more than 35 desks in this room. Without stacking them one on top of each other. I got up to 33 and thought I was gonna die.
Oh, yeah, cause that was like a whole bunch of desks has it on.
Okay. So if I wanted to include the 35, I would put a square bracket. If I didn't, I would put a regular parenthesis. Okay. So square brackets include parentheses exclude anything on either end. Okay, when you're looking at continuous, these are continuous. I should make sure. Jeremy, can you see that part of the board? Or do I need to scoot it back a little bit further? Okay, he can, good. Okay, does that make sense? I'll remind you of this like 40 million times. Just know that.
You're gonna keep on running about it.
All right, so set notation is a little bit different. It looks fancier. It looks more confusing. It's all in how you read it. Okay, you use the fancy little brackets like this. I actually really like writing this one because I like writing the little fancy brackets. Okay, for domain, you would say X, and then you would put a vertical line. And this says X such that. That vertical line means such that. Such that X, if we're doing this one, which is a discrete, equals 1, 2, 3, 4, and 5. And you would close it with a fancy bracket.
Oh, I remember this. My mom taught me this while I was being homeschooled.
Okay, and you would do the same with the Y's. Y such that Y equals 11, 12, and 13. Okay, once again, these ones are discrete. Some other really common ones that you will see will be ones like this. Let's see if you guys can figure out what this one is. Maybe you want to take a shot at that one. See if you know what that R symbol is for.
Whoa, but I feel like I've seen that on a calculator. Yeah,
Probably have.
because that's a calculator thing.
It's really not, but there probably is a button for it on the calculator. Okay, this says X such that X is in the real number system. It's a real number. What's a real number? All of those are both real numbers. Those are also integers.
No, negative.
Negatives are also real numbers.
Positive is true.
You guys don't hit the real complicated ones. The imaginary, there are things we call imaginary numbers.
Yeah.
And they were discovered
Oh, hey, you
by
guys.
someone who's trying to figure out some area issues.
Oh, hey. Is that okay if I read it? I can go get some water.
Yeah, then you have to have it.
Hey, Ty and Dave were talking about that.
Yeah, they were talking about that over the weekend. Okay, so imaginary numbers exist. You'll learn about them next year. Complex numbers exist. You'll learn about them next year.
A lot of
But
numbers.
they are not part of the real number system.
Let's just stick to normal numbers.
Okay. Integers, so you could also do integers, X such that X is in the integers. Have to be careful how you write these, or it starts to look like a Roman numeral too. Okay, if you see a positive right here, then that's positive real numbers. If you see a negative, it's negative real numbers. Okay, if we were doing set notation for over here, what do you think it would be? Oh, I just got really dizzy there for a second. Yeah, we're all right. What do you think our domain would be? X such that. Are there any limitations to our X values?
No. No.
Get to be imaginary numbers?
Yeah. No.
Any number you put into this has to be a real number. So it's gonna be such that X is in the real number system. This is an epsilon, it's a Greek letter, huh?
This is our first set notation.
This is set notation. Okay. If we're looking at this one though. Now we have some limitations, right? You said it can't be less than 0. Now all those like fabulous inequalities, less thans and equal tos and all that gets come into play. So now we're gonna say 0 is less than or equal to x, which is less than or equal to 35. So that's how we can limit it within set notation. You can use those inequalities. Does that make sense? Kind of, a little bit. That's right, today's more of a expose you to it. Make sure you've seen it.
Hey, now I can actually understand what people talk about whenever they do that.
It's hard when you're the youngest and your 2 older brothers are taking the same math class.
Yeah.
They talk about it over the weekend.
Did David paint a super complicated page of stuff?
Using imaginary and complex numbers, yes, we did.
Mhm.
Okay,
Just go ahead and just that one page with 25. And all the different stuff on it.
okay, so we're gonna do a couple examples. Because usually when we have a real world situation,
Whoa. Okay.
right, which is what y'all are gonna be dealing with when you grow up, real world situations. There are limitations, right, like there were with the desk problem. You can only fit so many desks in a classroom.
You can only
Right.
fit so many things inside your budget.
Yep. You can only, you know, you can't have negative amounts of flooring, you can't have negative amounts of paint, you can't have negative income, you can't have. So there are limitations in the real world.
The closest thing to negative income is being in debt.
That is true. I'm gonna get a full arm workout erasing this board today. It's gonna be a problem. Especially black. The black is so much harder to erase.
I add her to my list of pictures.
Yes, I found her in a pile on my desk on Friday. I was like, they're gonna be so happy. No, they're not. They're gonna be mad.
No,
Gotta revamp the whole poster because they did it so perfect. I know. I'm sorry. Found it underneath the folder.
The cards under this is for mentoring.
Okay, thank you.
Mentoring.
Marshall time.
Yeah. You can still call it mentoring.
Well, it's gonna take a while for that terminology to wear off.
And for everybody to stop thinking that Rockville Charter School is weird. But just having it not named Rockville Charter High School.
Okay. So here we go. Seriously, guys, I'm gonna have such a buff right arm at this rate. Probably not good since my right arm needs surgery.
You should start using
Okay,
solely.
probably
to
don't need
erase
this one
that.
either.
Solely just to erase the board, just only use your left.
Okay,
Only.
real world problem. Okay, so guys fill in a swimming pool. In his backyard. How many of you do that in the summertime? Get one of those temporary pools and fill it up. Okay, so a hose will fill. Hose fills a 10,000 gallon swimming pool. At a rate of 10 gallons a minute. Now don't try and move ahead or you're gonna be mad at yourself in a minute.
I just do a pool.
We're not gonna solve this problem because there's no question. What we are gonna do is we're gonna look at it and we're gonna say, okay, what would be a reasonable domain? What's a reasonable input for the amounts of water that are going in? So what would be a reasonable domain? Okay, our inputs are going to be time, right? How many minutes are we filling the pool? So what are some reasonable amount of times do you think? Ben,
An hour.
okay? Maybe 60 minutes? What's the lowest amount of time that we could look at? Could do 0, right? What if we didn't start filling it yet? Can we go negative?
No,
No, it's not gonna do us any good to go negative. So we are looking at a reasonable amount of time. It could be 60 minutes. Let's see. 10,000 divided by 10 is 1,000, so we could go as far up as about 1,000 minutes. Oh, look, I put $1. That's not it. Okay. So a reasonable domain would be from 0 to 1,000 minutes. Do we want to include those end caps? Yeah, we could look at it at 0 minutes. And we could look at it at 1,000 minutes. So that would be a reasonable domain. Is looking at it at 3,000 minutes gonna do us any good?
No,
No. So we're always looking, and I kind of like, after grading your guys' quizzes, kind of was annoyed that the book I'm using this year has this after, constraints after the word problems. Because some of your guys' answers were, like, if you had thought about the constraints, you would have been like, wait, this answer doesn't make sense. Okay, so our range, our output is what?
output is 10 gallons a minute.
That's our rate. So it's like our slope if we were graphing it or putting it into an equation.
Then it would be,
So if our input is our minutes, what is our output?
the amount that it is putting out,
The amount of water in the pool.
okay.
Okay,
0 to 10,000,
0 to 10,000. How come?
because it says those 10,000 gallons, but it could go less than that in a lesser amount of time.
Okay. Can it go over 10,000?
No,
No, because now it's overflowing. It's no longer filling the pool, right? Can it go less than 0? No, because you can't have a negative amount of water in the pool.
because the thing, if you have net to negative, they just do the zero.
Are we gonna include 0?
Sure. Yeah.
We're gonna include 10,000 gallons? So that means we're gonna use square brackets. You kind of getting what we're going for here? Like in the real world, there are limitations that just make sense. If I have a 3,500 square foot home and I'm looking to replace the flooring on one of the 3 levels of my home, is there any chance I could go over 3,500 square feet of flooring? No. Like if I do my math and it comes out higher than that,
That's not good.
really if it comes out of more than half of that. So my top floor is not the whole thing and my bottom floor isn't the whole thing. So if I go for more than half that, then I did math wrong somewhere and I need to go back and relook at my equation that I created or the math that I did and figure out what went wrong. Okay, so that's one of the biggest reasons we use this is because it lets us know, does my answer make sense? Okay, another problem. See, we're not solving for anything. Just figuring out what would be a reasonable range for us to look at. You're right, I should really start practicing erasing with my left hand.
Yeah.
I get what I want after
Can we do an
Christmas, we
example
might be
of a
doing some
not word-
slideshows.
Word problem or?
Huh?
Can we do an example of a not word problem?
Mm,
Words are-
we did a little bit when we did that first one, where we just used the table. That would be like a not word problem, where you look at the table or you look at the graph. I don't think I think your assignment might have a couple of those on there. I think it's mostly not word problems. Okay, so a restaurant needs to order some tables. Spell that right? Yes. As I was spelling it, I was like, am I spelling this wrong? Tell me you're not an English teacher without telling me you're not an English teacher. Here's the word I always misspell. Okay, so our input is going to be tables. Our output is going to be chairs. Because how many chairs we need depends on how many tables we have, right? So input is tables. What would be a reasonable domain? 10?
10.
Okay, probably. Kind of depends on the size of the restaurant though, right? Could be 10. Any other thoughts? What could be the lowest number of tables?
1 and 0.
0. We could choose not to have tables, right? Maybe it's a carry-out joint like Domino's is these days. Or Papa Murphy's or lots of places where you just go and get food and leave. Like, we don't want you to eat here. Go away. What's trying to think. Let's see, what are some restaurants around here and how many tables do we think they have?
McDonald's a lot.
McDonald's has $10, have a lot of tables.
Olive Garden.
Olive Garden has tons of tables. I haven't even wandered through that entire restaurant yet.
I have, and it's big.
Big.
Mm-hmm.
Make a guesstimate. How many tables do you think?
About like 50.
50?
Yeah.
50 times 4, that's like 200 people in the restaurant at a time. That's a pretty good number. Much more than that, you're probably looking at like a really big restaurant. Okay, so what would our domain be?
0 to 50.
0 to 50. And hopefully if you're actually buying these tables, you kind of have measured your space and know how many tables you can fit, right? If you're Quenchit, you have like the 5 tables. If you're Olive Garden, you got 50 to 100 tables. So if that's the case, what would be a reasonable output?
Yep. Is chairs, right?
Yep. And each table should have 4 chairs.
So whatever 50 times 4 is would be the max.
Yep, perfect. 0 to 200. Okay, so now knowing this, I'm gonna ask you a question from your quiz. There was a question about my age is, what was it? 120 less than 4 times,
It's.
or let's see, 500 less
Reduced-
4 times my,
It's-
reduced by 4 times my age is 120 or something like
I
that,
think it was 2 times.
something like that. What would be a reasonable answer? What would be a reasonable output? Anything about below 100, right? It's not a lot of people living over 100. So if your answer came out as 200, that should have been like a red flag. Wait a minute, who's 200 years old? This isn't exactly, Middle Earth or something. Right? This guy's probably not a dragon. Not Dumbledore or one of those guys. We already did that. We already did that. That's everything. Woohoo! Okay, let me grab your assignment. Put two different kinds of problems on your assignment. I put graphing ones. And I put mapping ones. Now, I'm gonna read you the directions. Cause I know y'all are gonna just automatically jump to conclusions when you see it. Okay. So each graph represents a relation, so it's giving to you that there's a relationship between the inputs and the outputs. Determine if it is a function, then find the domain and the range. Okay, so we'll do number one together. So pull up the assignment I posted, Jeremy. Well, I pass this out to everybody else. Here standing in front of So you guys gonna be tempted to overcomplicate this? Let's not overcomplicate this. Okay, so number one is a graph. Look, it's gonna be so hard because you're in dominant right hand. The chance of me drawing this perfectly is very, very slim. Just think y'all should know that right now. Up front, this is not gonna be a great drawing. They don't make math teachers take art classes. So I several times have contemplated why that is. Just under 5. There. They're touching at 3, 2. Touching at -7, 2. See how good I am at drawing ovals, shall we? Not very good. Not a great football team.
That's good.
Okay,
You just drew it to the dots.
I did. Okay, so what would my domain be? What are possible X values here?
X, so anywhere from -7 to 3.
Are we including -7 and 3?
Mm,
Yes? Okay, so I'm going to use the square brackets.
Wait, how did we get -7 and 3?
Because the furthest it goes this way. 1, 2, 3, 4, 5, 6, 7. The -7 is the furthest it goes this way. And 3 is the furthest it goes that way. So you're just looking at the horizontal when you're looking for your domain. Right? See as far left as it goes and as far right as it goes. Okay, so I say you're gonna try and overcomplicate this, don't just see how far does it go this way? How far does it go this way? Do I include those numbers or not? Okay. What about our range? Range is how far up and down it goes. Lower number always goes first. So how low does this go?
I'll see if you did 1.
Okay, and how high does it go?
5.
Okay, are we including -1 and 5?
Yeah.
Do they touch those? Yes. Okay, is this a function?
Yes. No,
How come?
because it's a circle and it has.
And it's
on
not
the
a straight
vertical
line.
test.
Okay, it doesn't necessarily have to be straight to be a function.
It doesn't pass the vertical line test.
There we go, that's actually what I was looking for. It
Yes.
doesn't pass the vertical line test. If I draw. It's just that.
You draw a line like right in the middle.
If I draw
You draw line
a vertical line,
anywhere.
does it cross it more than once?
Yes,
The answer is yes,
always.
it is not a function. So because it crosses that twice with a vertical line, it is not a
Where does
function.
it cross twice?
So it crosses like this one crosses right here and right here,
Oh.
crosses right here and right here. Make sense? You okay with it? Okay, let's look at number 6, I think is the first mapping one. Okay. Never gonna remember to do everything left-handed. Okay, our inputs are -5, -1, 3, 5, 6, 7, and our outputs are 1, 4, and 5. This. Okay, so what is our domain?
The domain is. -5, 7.
Except there's just very specific numbers, right? So this is when we're gonna have to use those parentheses and create our list inside of it. Right, so it is. -5, -1, 3, 5, and 7. Cause it can't be 2, it can't be 0, it can't be 1, it can only be one of those numbers. Okay. What is our range?
1, 4, and 5.
1, 4, and 5. Is it a function?
No.
Yes, it is.
Here, yes and no. Let's hear your arguments.
Because
Looking at it
there's
wrong,
no.
at least,
there's
right?
no
Okay.
lines coming from.
Cause each one of these only have one line coming off of it, right? Okay, so this is a function. Okay, that is all there is to your assignment. You have 15 minutes till class gets over.
Wow, cause I'm like very fast.
Shouldn't be too bad to get the remaining 8 problems done in that amount of time.
That's it.
That's it. That's all you have to do. Don't overcomplicate it.
Looks simple.
Brinley, I know you're gonna wanna complicate it. Don't.
That
Okay.
looks simple.
I'm, okay, give me just a second. Jeremy, cause I published it this morning. I don't know why it's not showing it. You're gonna have to go into modules. There's not a button yet. I forgot to create one last night. And I can't create them on this computer. All right, see if it's there now. I just told it to do it again.
The background looks more simple to do than the front.
Cause it's not graphs. Do graphs freak you out?